Good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for the month of August. Once again, my name's Warwick Rudd. I'm hosting this session for you today, and for this month's session, we've got Victor Isakov talking to us about SQL Server 2017 database engine enhancements and why we should upgrade to SQL Server 2017. Now, I will hand over to Victor in a couple of minutes. I do have some housekeeping to run through. So first of all, those of you who may or may not know, Pass Summit is quickly approaching. If you haven't already registered, we do have a discount code on the next slide for you. But a big shout out to our sponsor, SentryOne. Without our sponsors, we wouldn't be able to put on this session for you. So if you haven't already gone to their website, make sure you go and have a look at their articles, videos, downloads, etc., and broaden your SQL Server learning. As I mentioned, with Pass Summit 2018 coming along, if you still haven't bought your tickets, if you use either of the two discount codes available here, you can save $150 off of your purchase price. Make sure that you go and do that, and you'll see some fantastic sessions over the week in Seattle. Now with that, there are many other virtual chapters available that you can register for events such as these. So make sure that you go to Pass, have a look at the virtual chapters that are suitable to you, register for those, and be notified about these particular sessions. So with that, I'll now hand over to Victor to run through this month's session.
Okay. Let me, I'm not sure if people can hear me yet. Let's just confirm with Warwick. Warwick, can you see my screen?
Yes, we can see your slide deck and we can hear you.
Okay, fantastic. Okay, well, good morning, good afternoon, everyone, depending on where you are in the world. So welcome to this session on SQL Server 2017. This particular session is really focusing more on the database engine and hopefully helping you build up a business case or a use case for why you should be upgrading to the latest version of SQL Server, which is 2017. So again, SQL Server 2017 was a little bit unexpected, I think. So people didn't expect it to be released so soon after 2016. The primary reason for that was fundamentally because SQL Server on Linux wasn't ready to be released when SQL Server 2016 got launched. So Microsoft had to delay and sort of put in an interim release of SQL Server. So that's why we've got this SQL Server 2017. So certainly I would be expecting a version of SQL Server, be it SQL Server 2018 or 2019, reasonably soon based on that logic. In any case, a lot of people think that we don't need to upgrade to SQL Server 2017 because it's pretty much just a Linux release, but that's definitely not the case. So what's happened in the last 10 months or whatever it's been between the 2016 and the 2017 release is that various product groups, teams have been working on enhancements inside SQL Server. So there are actually some compelling reasons as to why you would be upgrading to SQL Server 2017 versus 2016. So people are comfortable with upgrading to 2016, but a lot of people are saying, well, what's the point for upgrading to 2017? It's a Linux release, so it doesn't really apply to us. But actually, there's some really, really nice enhancements, and that's what we're going to concentrate in this particular session. So ask questions along the way. Warwick will take care of them. We have a lot of content to cover. We'll see how we go with it. The content towards the end probably isn't as strong because it looks a little bit at SSIS and things like that. So we're focusing more on the database engine initially. So let's get underway with this journey. So as you can see, the primary focus of this particular session is going to be really talking about the database engine on Windows and what has been added or enhanced in the database engine itself there. We'll cover off a few little other peripheral technologies, but we're focusing on that. So we're not really covering SQL Server on Linux, we're really covering SQL Server 2017 on Windows, what enhancements have been put into the database engine that make it a compelling reason to upgrade to it over 2016 as an example there. So there's been a lot of polish added to SQL Server 2017, and that's reflected in the next point there, where a lot of subtle changes and a small handful of major but potentially important enhancements in the database engine, and we'll be obviously looking at them later on inside this particular slide deck. So again, we're sort of assuming that you're familiar with SQL Server, you know, familiar with the feature set, you're sort of at a high level familiar with what's the difference between SQL Server 2016 and 14 and what's been released in different versions of the product itself there. So let's get underway. As I said, this particular slide deck is just a list of all these different enhancements. Some of them might be really important, some of them won't, but overall we're trying to build up a picture of what's changed between 2017 release and early versions of SQL Server. So the first thing that we're going to look at is just this little bugbear that's been in the product for quite a long time. And I was actually involved in the discussion as to the history of that, so I'm not going to bore you too much with it. But you might have noticed that whenever you install SQL Server over the last decade or so, we're always installing the SQL Server 2008 setup support files there. So it was a known issue with upgrades and installing different versions of SQL Server that meant that Microsoft had to keep these support files, these files inside the SQL Server installation. So they finally got their act together and cleaned that up. So as you can see, starting with SQL Server 2017, when you install this particular version of the product, you won't have to have these old legacy support files because they cleaned up the underlying problem issue that was existing in the database engine, which sort of caused problems when you're doing upgrades and things like that. So just one little change, cosmetic change that you will see. The next thing that you'll notice if you're installing SQL Server 2017, and again, I see a lot of questions on the web around this as well, is that reporting services is no longer part of the SQL Server setup. So in earlier versions of SQL Server, you'll recall that we had books online and we also had reporting services all in the ISO, so everything was installed from the ISO. Then we had updates via service packs and cumulative updates. We had books online updates as well. So Microsoft decoupled books online from the product installation itself. There was a separate download. SSMS is a separate download as well now. So for 2017, you'll notice that when you install SQL Server from the ISO, for example, you'll see that you don't have that option of selecting reporting services. So again, you'll see there on the left-hand side, SQL Server 2017 setup, and you'll notice that there is no reporting services. And at the top, it's telling you if you're looking to install reporting services, you need to install it from the web. So it's a separate download itself there. So clicking on that hyperlink will take you to Microsoft's download website. So again, a little bit of a backstory without boring you too much is that SSRS now is sort of being released in its own cadence. So it's being released in a different cycle from SQL Server itself, if you like. So it's going to be a separate download itself there. So again, you can see the URL there where it can be downloaded, and it will be updated every so often with new functionality, etc. So I think there's going to be an August release of reporting services that's sort of coming out imminently. So again, it's a separate download, different from the database engine. There have been some changes in reporting services as well, so just be aware of that. So you might have some problems with upgrades and things like that with what they've done with reporting services in 2017 versus Power BI reporting services 2017 and default instant name support, etc., named instance supports. So just again, do a bit of reading on that if you're upgrading to SQL Server 2017 and you are using SSRS, because you might have to re-architect some of your SSRS architecture, if you like, there. So, and that's actually reflected in the next slide, as you can see. So you can see over here, we're basically pointing out that you can't do an in-place upgrade of an existing SQL Server 2016 or earlier version of SSRS there. You can install SSRS 2017 as a side-by-side. And this has to do with the fact that in 2017, they sort of hard-coded the instances for the Power BI report server and the standard report server as well. So over here, as you can see, they're saying that SSRS now installs as a SSRS named instance as opposed to a default instance. The powers that be at Microsoft decided to do this. This obviously has caused some pain with upgrades and caused other problems. So I expect this to be removed in the next version of SSRS/SQL Server. But as I said, just be aware of that with 2017. So do a bit of research on this if this is going to potentially impact you. The thing that Microsoft have also done since releasing SQL Server 2016 is paid a lot to feedback from various folk around the world, be they customers, MVPs, other people of influence. So you'll notice that, as I said, in 2017, there's been a lot of polish added to the product, and the same can be said for SQL Server 2016 Service Pack 2. So a lot of feedback from the industry. So Microsoft have been busy tweaking and adding a little bit of polish to the product. And this particular slide represents that. So again, a lot of people were giving Microsoft the feedback that when you install SQL Server 2016, they basically changed the way TempDB gets installed. So it doesn't by default only install one TempDB data file, etc., as it has in the past. So depending on the number of CPUs that it detects, it will install TempDB with a number of different files to reflect best practice in the industry. And the commentary or the comments that people were making is that you couldn't choose an initial size greater than, I think it was 250 meg or whatever it was, I can't quite remember. So maybe it's there, 1 gigabyte. So basically they just gave Microsoft the feedback that in the install engine, can you please give us the capability of creating a larger TempDB because we have larger environments. So you can see over here, we've got just a little tweak added to the setup program where you can have an initial size that's much larger in this particular case for the TempDB. So again, just a small subtle change that was added to the product. The big news in terms of differences between SQL Server earlier versions in 2017 with respect to patching is that Microsoft have pretty much done away with service packs. So again, it's always difficult for Microsoft and difficult for customers with patching. So what do? You know, people don't like to install cumulative updates. They only like to install service packs. Microsoft have been communicating for quite a long time that cumulative updates are the same as service packs. So you should be using and updating cumulative updates. They've also said that a lot of customers that are updating to the latest cumulative update are not seeing a lot of issues that other customers who don't do that are seeing with respect to their own internal telemetry. So again, Microsoft have been really promoting cumulative updates. From Microsoft's engineering point of view, sustained engineering, there's a lot more work that needs to be done with service packs, I think, compared to cumulative updates, even though the quality bar is the same. So Microsoft really didn't want to release service packs. I think they just wanted to go to cumulative updates. It's obviously my personal opinion. So you can see inside SQL Server 2017, for the first time, they're basically saying we have no more service packs. We now will only be doing cumulative updates. I was actually of the opinion they should be changing the name so that we don't have any baggage associated with the term service pack or cumulative update, but we're sort of keeping with that terminology, if you like, there. The other interesting thing that they've done with cumulative updates is that obviously when a product gets released, there's probably going to be more bugs in the product. So as the product evolves over, so as time evolves, obviously there's going to be less and less patches or fixes, if you like, inside the cumulative updates that are released. So again, you would have noticed that when cumulative update 1 comes out and 2 and 3, there's a lot of bug fixes. But by the time we get to cumulative update 10 or 12 or 9 or whatever the case is, there might only be 4 or 5 or 6 bugs that have been found and need to be addressed at that particular point in time. The other problem with patching is, with respect to cumulative updates, is the frequency of them. So again, it's very hard for Microsoft to find an answer that satisfies all people. So traditionally, cumulative updates have been delivered every 8 weeks, which is on a 2-month cycle. So what they've done as of SQL Server 2017 is quite interesting, because what they've done now is said that for the first 12 months, we will be releasing a cumulative update every month. So expect 12 in the first year, effectively, after the release of the product. So obviously they're sort of saying that's going to geared towards probably us finding more bugs in the product that need to be fixed in the first 12 months. And then sort of things stabilize, so we don't want to burden you with having to patch every month. So what we're going to do with cumulative updates after the first 12 months is patch every quarter. So effectively for the next 4 years, you'll only be getting 4 cumulative updates. So there's going to be less for you to patch. And then it's sort of predictable as well, as you can see. So cumulative updates, 2 through to 11 in the first 12 months, and then 13 through to 27 over the next 4 years. Of course, if there is going to be something serious, such as Slammer or these other CPU-related bug fixes that needed to be addressed, which was security vulnerabilities, that will be coming out on demand. But in general, with cumulative updates, that's the story for that. So that's what's going to be happening with SQL Server 2017 going forward. The next couple of slides are going to have a look at some new DMVs that have been added to the product. And again, it's quite interesting because some of these DMVs I'm pretty sure would have been released as a result of user feedback, community feedback to Microsoft that basically said, oh, that's really a good idea. Let's bake it into the product. So I don't know, some of this stuff might be retrofitted into earlier versions of SQL Server. Some of it might not, but it's opening up some new possibilities, which I'm pleasantly surprised by. So the first one that we're having a look at is a new DMV that's going to replace DBCC log info. So again, DBAs might have to look at DBCC log info to see, why is a transaction log not able to be shrunk? We need to work out how many VLFs exist, how many of them are active, are they at the end or the beginning of the transaction log, etc., etc., etc. So again, we had to run all of this cryptic DBCC log info, which wasn't documented, etc. So again, it was about time that Microsoft represented this information as a DMV. So you can see we've got this new DMF actually, which is sysdmdb log info. So we can query that relationally, select star from this particular DMV, pass in the database ID, as you can see through those two functions there. And then we're going to get the same information as DBCC log info. So again, a nice new little tweak to the product itself there. The next couple of DMVs, as you can see, are just going to reflect the fact that we're hosting SQL Server on different operating systems now. So again, we're not just supporting SQL Server on the Windows operating system. We also support now SQL Server on the Linux operating system as well. So you'll see that reflected in a couple of the DMVs that sort of tie into the operating system host information there. So again, you'll see that we've just enhanced DMOS sysinfo, so we're getting more information about socket count, cores, NUMA node counts, etc., which can be good for a number of reasons, obviously including licensing. And then you can see from DMOS host info, we're going to see other operating systems as well. So you can see in this particular example, we've got a Linux platform with a CentOS distribution over here. And we can also now track version store information or version store usage per database through DMTran version store space usage as well. So again, not globally, we can track it on a per database instance as well. So some really nice enhancements additions there. This one's quite interesting as well. So this is looking at giving you new information about the usage of the transaction logs for your particular databases. So you can see that we've got this new DMV called DMDB log stats. So again, we're passing the database ID to it. And again, you will see we've got this sort of information presented about it. So current VLF sequence number, the size of the current VLF, the total VLF count, the total size of the log, how many active, these sorts of things like that. So some useful information there. Because again, as you can see from the slide, we're sort of pointing out the transaction log always was a bit of a black box. You can't get too much information. We've got all these cryptic little DBCC commands. So now they've exposed this information relationally through these DMVs. So we've got stats, statistics, telemetry about the transaction log itself. That's actually quite nice. And you'll see that reflected in a short while in the two more slides there. So again, you can see we've got a really nice column there, the log truncation hold up reason. So we can't truncate the log right now because we're doing a checkpoint. So very easy for you to work this out over here. Now, the really smart or nice thing about this is that it's also enabled some functionality, which I never have thought about, which is enabling smart transaction log backup. So we're going to have a look at that over the next two slides. And that's fundamentally because they've put in the plumbing or the architecture to allow us to do much smarter transaction logs and differential backups. So you can see, on this particular page down the bottom, we basically have a much smarter transaction log backup. So a lot of people, for example, have a backup strategy, which is backing up the transaction log every 15 minutes. But you might not have a lot of activity during that 15-minute period. So potentially you're saying, look, we need to back up the transaction log every 15 minutes, which is fine. But most people are only doing inserts, updates, and deletes during business hours. So let's say between 9 o'clock in the morning and 5 p.m. in the afternoon. So outside that particular time frame, there's not a lot of activity, let's say, inside the database. So we're still doing a backup every 15 minutes. And the backup might only be 1 megabyte in size, or half a megabyte in size, or 500K, whatever the case might be. So again, when we restore the transaction log, restore the database, we have to restore all of these minuscule transaction logs. So obviously somebody gave feedback to Microsoft, wouldn't it be good for us to be able to do a transaction log backup based on the size of how much activity has been pumped into the database, and therefore the size of the transaction log? So you can see over here in the DMV, we've got this active log size _ megabytes. So what you can conceivably do now is say, I want you to back up the transaction log if the size of the transaction log grows to larger than 10 megabytes in size, or 50 megabytes or 50 gigabytes in size there. So again, the idea here is if you don't have a lot of transaction log activity, you're not doing all of these needless small transaction log backups. So again, it's giving you the flexibility. It would be nice if they provided tooling for it, but at this particular point in time, we don't have that tooling inside SSMS. So you're going to have to build your own scripts that are going to rely upon that. Okay, so again, a nice new feature in the product, which is enabled by this DMV. The next particular slide is looking at smart differential backups, which is sort of looking at differential backups, but trying to do the same thing. So again, you might be doing differential backups at the end of each day. And again, certain days there might not be a lot of activity. Alternatively, your differential backup is growing and growing and growing until it reaches the size of the full database. So instead of maintaining to do differential backups for the remainder of the month, you might be better off doing a full database backup, resetting the differential change map pages, and then initiating differential backups again there. So again, this is long overdue and a very nice feature in the product, where as you can see, we've got this modified extent page count that has been introduced into the DMDB file space usage. So again, they're underlined inside this particular slide in red here. So this now again gives you the capability of having an intelligent differential backup, where you can say that if the differential page count gets to a certain size, so it's approaching the size of the database, etc., that we can kick off a full database backup. So again, there's no capability inside the product natively, so no tools inside the database maintenance plan wizard, etc. That might come later on, but the plumbing is there. So we've got these DMVs that effectively enable you to work out how much of the database has changed, and then potentially not perform a differential backup, but kick off a full backup. Or alternatively, you'll notice that the differential backup shouldn't be done because we haven't modified enough extents between yesterday's database activity and today's database activity. So again, there might not be any need for us to do a backup. So it's giving you this capability, if you like, there. Again, it's up to you whether you want to leverage this functionality. The next little option is looking at a new database scoped configuration option. So there was an existing configuration option, but that was global inside SQL Server. It was trace flag 272, which is documented in books online. So basically it controlled whether or not, or what it tried to do was prevent gaps in identity properties by not caching things. So if the server crashed, you'd be losing stuff inside the cache there. So you had this trace flag 272 that was at the server level, so it applied to all databases. So again, feedback to Microsoft, fairly obvious. We would like that at the database level, not at the server level, if you like there. So we've got this new database scope configuration option, which is identity cache, which can be turned on or off, which is going to have the functionality of what trace flag 272 did at the SQL Server instance level itself there. The other change, as you can see, has to do with a self-signed certificate. So again, you'll see that up to SQL Server 2016, the self-signed certificates were created using the SHA-1 algorithm, whereas starting with SQL Server 2017, the self-signed certificates now uses SHA-256 algorithm instead. So obviously that's more secure. So again, just be aware of that. And again, possibly change backup certificates, watch out for restores, those sorts of things, etc. The next couple of slides look at something that Microsoft has been working on for quite a while, and I'm wondering whether this is a result of them having to eat their own dog food in Azure or not. But you can see we have the capability now of resuming online index rebuilds. So this is only available the Enterprise Edition. But again, the idea here behind this is that you might have an index rebuild operation that's occurring on a very large system. So you have that database hosted on a LUN or something like that. So for whatever reason, one particular day, it takes 4 hours to rebuild that particular operation. But let's say 3.5 hours into that particular index rebuild, you run out of disk space for whatever reason, just more activity that particular day there. So what will happen is that particular index rebuild will fail. We have to do a rollback. So we've basically wasted those 3.5 hours. So what you now have the capability of doing on SQL Server is saying that an index rebuild can be resumed. So the idea here is, in this particular case, what's going to happen is you try to do an index rebuild. It's going to take 4 hours. After 3.5 hours, that particular operation fails, but you now have the capability of saying, okay, let's address this particular issue. So let's add more space to that particular LUN, and then we can continue that index rebuild operation. So it just runs for another half hour to complete, and then everything is fine after that. So again, you have the capability of resuming an index rebuild operation after the failure of that particular operation. So running disk space, the other obvious use case is that you have a failover operation. So you didn't run out of disk space, but for whatever reason, something went wrong or somebody did a failover. So again, clustering or an availability group. So you failed over the database from one instance to another instance. And again, that's going to basically roll back that operation. Whereas now what you can do is you can resume that index operation there. So obviously a very, very nice feature of the product. And you can see the syntax down the bottom there with this example of altering an index on the order details table. And in the options, we're saying it's online. So online is equals on, resumable is equal on, and we've got a maximum duration of 240 minutes there as well. So this is just giving you some more information about this capability of online index rebuild, resumability, and pausability. Trying to invent some new words there. So you can say alter index on order details pause. So when you have this capability, as you can see there. So again, some points over here, some limitations. So obviously when we're doing these index rebuilds that are resumable, so it can be paused and resumed, so pause and resume, there's going to be no blocking. However, we're going to obviously consume more disk space because we're keeping track of what we've done so far so that we can resume that paused index rebuild there. There's no schema changes allowed to the underlying tables until that index rebuilding operation has completed, etc., as you would expect there. So again, Microsoft has really tried to mitigate the performance overhead of this. So again, saying that performance is similar to a regular index rebuild with no additional resources overhead. So it's just space really in terms of consumption over there. And the other limitation down the bottom is that you can't use the sort in TempDB for resumable online index rebuild. And that should make sense because if you fail over from one instance to another, obviously we have different TempDBs. So the temporary structures and what we've done with the sorts and what we're doing in the background obviously needs to be kept inside the database. So again, we can't use TempDB for these sorts of operations. Down the bottom, an example of how you would abort such a resumable operation. Another improvement inside SQL Server 2017 is that you're just going to have an improved backup speed. So basically what we've in this particular case is leveraged indirect checkpoints. If you're interested in this in more detail, you can click on that link down the bottom there that says blog. And I think Bob Dawes posted a blog post about what they've done in this particular case there. I don't see this as being a big deal. Again, I suspect this is probably more internally for Microsoft than Azure, possibly where people might be running a large number of small databases, I'm not sure. But you can see they just basically said, we've just improved the backup process by using the indirect checkpoint. So we've removed this iterative buffer scanning to make sure that we do the backup quicker. So they've done some testing on this, and you seem to have an improvement in backup speeds for smaller versions of databases. So they were again saying that under half a gigabyte, 100x improvement in performance, around 1 gigabyte, 30x improvement in performance, 10 to 100 gigabytes, 2 to 6x improvement in performance. And once we get to 100 gigs to 500 gigs, about 10 to 20%. So I'm not too particularly fussed about that because, again, I think, well, who cares if you've got a small database and it's, it's not going to take long in any case there. For larger databases, the improvement isn't as big. But again, conceivably, you've got a system where you have a large number of small database and you're using something like the database maintenance plan wizard, which backs up all the databases serially. So again, if you're backing up a large number of databases serially, then the overall maintenance window consumption is going to be much larger. So again, in that particular use case, you're going to see a nice improvement because it's going to take less time there. So just be aware of that. This one I never thought of, but obviously an enhancement that somebody's added to the product. So this is more for a data warehousing use case context there. So they've just extended the select into take a capability for you to be able to say select into a table. So it creates the table on the fly, but you have the capability now in SQL Server 2017 of specifying a file group where that particular new table will reside. So the new syntax in SQL Server 2017 with the example down the bottom, select star into factory seller sales Excel on file group 2 from the factory seller sales table. So a nice little new addition that's been added to the product. So nothing more to add to that. From all indications, it seems that the CLR has become a security problem. So you'll notice that Microsoft, if you kept up with what's happening in Azure, supported CLR, and then after a couple of months, they removed CLR and didn't want to say too much more about that. So what Microsoft have done inside SQL Server 2017 going forward, you might recall we had the capability of creating assemblies that were unsafe, safe, or external. So what Microsoft decided to do in SQL Server 2017 going forward was basically say that, we sort of really don't want safe external, everything's treated as unsafe, if you like, there. So the idea is that we really want to restrict a CLR capability, let's say, in the product. The problem, of course, is that that's going to break existing code, etc. So I do recall some messages and emails flying around internally with what should we do in this particular case. So again, we'll see what the potential solution is in the next slide. But just be aware that inside SQL Server 2017, we have this new SQL Server configuration option, which is saying that by default, we're sort of not allowing CLR, so CLR Strict Security is turned on. So again, be careful with upgrades. In general, remember that if you're doing a side-by-side migration, so install a new version of SQL and then you're migrating databases across, some of the configuration options might have changed, so you will have to change them. If, however, you are doing an in-place upgrade, so you are upgrading an existing SQL Server X to the latest version, then those configuration settings should be preserved. So again, by default, CLR Strict Security is going to be turned on, but if you upgrade an existing SQL Server instance, an in-place upgrade, the setting will be turned off. So going forward in SQL Server 2017, we're sort of recommending that you have this strict security going on. So what do you do with your existing assemblies? We have got one of two options there. So again, number one, sign all the assemblies and grant unsafe permissions to the login, okay? And that obviously was not a tenable solution for some people. So for backward compatibility, what Microsoft did was add this sp_add trusted assembly. So what you're effectively doing is whitelisting existing CLR assemblies. So again, going forward, the recommendation would be to use strategy number 1. Okay, but if for whatever reason you can't, and this is obviously going to break existing applications and be a blocker to upgrading to SQL Server, then what you can do is whitelist the CLR assemblies using the hash value, as you can see. Okay, so that's something to be aware of with upgrades. So as I said, if you're using CLR, do a little bit more research in this particular space. Let's move on to always on improvements and see what's happened in this particular space. So this for me was a blocker in a lot of customer sites as to why customers couldn't upgrade to the later versions of SQL Server and use availability groups. So they either had to stay with clustering. So they basically had to stay with clustering, so they couldn't use availability groups there. I think there was a bit of confusion in the industry because in early versions of availability groups, we had no support for DTC. In 2016, we had partial support, but from my point of view, for all intents and purposes, the partial support that we had was not sufficient. So again, it wouldn't meet most people's scenarios where they want DTC working between databases in the same availability group, which is the most common use case I would suggest. So again, people couldn't use that in 2016. So this was a joint effort between the Windows Server team because it has to do with clustering, it has to do with DTC, and then SQL Server leveraging the capability of the Windows functionality there. So finally, inside SQL Server 2017, we have the capability of deploying database solutions that need full DTC support there. So we have full DTC support in availability groups, starting with SQL Server 2017. So again, we're just giving you a little bit of a history there with SQL Server 2016 added support for distributed transactions across SQL Server instances. But now we have the full support, so we have cross-database transactions within the same availability group running on the same SQL Server instance, which is, as I said, what most database systems such as SharePoint, maybe TFS, etc., use. Sitecore, where you have multiple databases in the same availability group traditionally, and you have distributed transactions across those multiple databases within the same availability group. So hooray to Microsoft, finally got that into the product. So again, that's removed a major blocker from adoption of availability groups with respect to DTC support. There's been a lot of work done in the HA space, especially with the introduction of Linux being supported as well. So this is something that I've been asking for a long time as well, and of course other people have as well. And this is the capability of you wanting to have an availability group, so another replica somewhere, but not having it as part of a cluster. So you're not interested in high availability. You're not going to fail over to this particular replica. For example, you just want to use this particular replica for reporting purposes. So we're never going to fail over. We're not interested in high availability. It's just for reporting purposes. So what we want to do in this particular case is just have another replica. We're going to report off it, and we don't want the administrative nightmare of making it part of the cluster, etc., etc., etc. So again, we now have the capability of having clusterless availability groups. So again, primary purpose is going to be for read-only secondary replicas. So you can never fail over to them because obviously they're not part of the cluster, but that's not a nice new addition to the product as well. I suppose you could also use it for disaster recovery as well. You might have bad WAN links, etc. So yes, but the primary purpose is used, as I said, for read-only purposes. So that's a nice new addition to the product as well. The next slide is just talking about read-only scale replicas in more detail there. So again, we don't have the reliance upon clusters, so they're called clusterless read replicas. So again, you have no high availability, so you can't fail over to them. You can obviously offload reporting to it, as we have discussed, but you could also offload your database consistency checks and backups onto that replica if you so desire as well. You can have a hybrid availability group solution in this particular case. So what you could do is mix a SQL Server on Linux with SQL Server on Windows. So again, you can do that as well. The other thing that they've added to the product availability group functionality-wise is having a minimum number of synchronized replicas, secondaries, before something is committed there. So again, this is a feature that has been added to the product, obviously based on customer feedback. I certainly wouldn't have thought of this, and I don't think I have any customers that would want this. But what you can do is say, with this particular setting, you're guaranteeing that a primary replica has a minimum number of replicas committed before a transaction is effectively considered as committed. So again, ensuring safety. So you're ensuring that the data changes have been committed to 2 other replicas before it's considered to be committed, as an example there. So you have this minimum number of replicas to commit. So again, triple redundancy if you so desire there. This particular slide is just showing that you've got capability of building a hybrid HA solution. So you have the capability of mixing Windows and Linux as the operating system with your availability groups. And this again is because what we've fundamentally done is move the high availability into the application space. So we're not doing things at the Windows layer or the Linux layer. What we're doing, everything is at the application layer in SQL Server in this case here. So you can see in this particular example, we basically have a Windows environment and a Linux environment, and we have a hybrid availability group. And again, this is a culmination of different technologies, be it Windows, clustering, Linux, pacemaker on Linux, but also distributed availability groups and these sorts of things like this. So again, for extremely paranoid organizations, if you want to protect operating system failure as well, you could possibly also have this hybrid high availability solution to have redundancy at the operating system level. So conceivably, in this case, for this extremely paranoid organization, you might have some sort of a 0-day exploit to your Windows environment. All of your Windows system servers go down. So that would affect all of the replicas in that AG environment that are running on the Windows Server operating system. But in this case, you're protected against that because you also have SQL Server running on Linux, and you've got this hybrid HA availability group solution set up. So we would fail over to the Linux environment in this particular case. So yes, we are allowing this sort of a scenario there. So it is also useful for other purposes, be it migrations, testing, reporting services. But as I said, you could also protect against operating system failure at this level as well. 2017 has some, now we're moving more into the programming space. So this for me is a couple of really big deals here coming up. So the first thing that we're going to talk about is Query Store. So SQL Server 2017 has expanded Query Store in a big particular way. So you recall that Query Store was added to SQL Server 2016. So you have the capability now at the database level of enabling Query Store. And what it will do is track query execution, which allows you, as you can see from this particular slide deck, troubleshoot query performance in hopefully a few minutes, find query regressions, identify which particular queries have been consuming the top IO or the top CPU or whatever the case is. So it's helping you with optimization, troubleshooting, etc., etc., etc. So it's also very, very useful for upgrades, which is for all of my customers. I'm always pushing SQL Server 2016 over 2014. So again, people might be running on 2008, 2008 R2, 2012. They want to upgrade to 2014. And I'm telling management, no, let's upgrade to 2016, because with Query Store in 2016, you are mitigating your risks of upgrading and being able to detect query regression because of Query Store. So the idea here is you upgrade from an earlier version of SQL Server to 2016. You keep the database compatibility level at SQL Server 2000, whatever it was, 2012, 2008. You then enable Query Store, run Query Store for a week or a month, whatever you feel comfortable with, then flip the database to compatibility mode 2016, and then Query Store will hopefully pick up any query regressions. So the idea here is that will actually help you with the upgrade and help mitigate risk, which is why, as I said, of upgrading, of why I promote upgrading to 2016 over 2014, because otherwise they're very, very similar database engine-wise. Now, the big feature in Query Store that's missing in 2016 has been added in 2017. So the big thing that they've added to SQL Server 2017 Query Store is that we also now track weights at the query level as well there. So now what we can do is ask questions of, we've got the query, but now we can see what queries are waiting most on page IO latch. So now because we keep telemetry at the query level on waits for locks, latches, memory, networking, HADR, etc., IO, we can now troubleshoot queries a lot better. So we're now keeping track of waits at the query level as well. So you can see in this particular example on this particular slide deck, we've got a query there. So you've got the other things that you've had before, such as the plan count, the execution time, the query plan, etc. But you can see now we also have the different weights. So for this particular query, the total wait time was 1094 milliseconds, but we can also see the memory wait time versus the CPU time versus the buffer IO versus the network IO wait time as well. So this is a great overdue feature capability inside Query Store that has been added to the product as well. Okay, so again, this is worth upgrading to SQL Server 2017. And apologies if you can hear my little 5-year-old Marcus Isakov complaining about something in the background. Marcus, people around the world are saying, go away, they want to listen to SQL Server. Shh, shh, shh. Okay, so because of what Microsoft have added to Query Store into the product, it's enabled them to evolve that particular product in a number of ways. So this is something that you might be aware of that's now being introduced to the product, which is automatic tuning of your query performance with SQL Server. So again, we're leveraging the capability of Query Store. So because we're keeping track of telemetry of Query Store, we're keeping track of execution plans and telemetry about execution, etc., we could do some really, really interesting things. So in this particular example, what we're talking about is that if all of a sudden your query performance goes south, SQL Server has the capability of automatically using a previous execution plan which it thinks is better. So there's some heuristics and logic in the background where it's captured the performance and execution plans in the past, and all of a sudden if query performance goes bad, it can use the last good execution plan. So the syntax is alter database current set, or in this particular case, it's current set automatic tuning, and in brackets, fourth last good plan is equal to 1. So obviously that's highlighting or hinting at the fact that maybe in the later on, you can have different policies. So at this point in time, it's the last one that was good, as opposed to the best one ever. So again, this can change over a period of time. And you can see in the example screen capture down the bottom, we've got different execution plans in yellow, blue, and green. So execution plan 1, 2, and 3. And what we've done in this particular case is, for whatever reason, you can see that around 70 and 60 down the bottom, plan number 4, the query performance was really, really bad. So we've got a spike in CPU usage. So we've gone from an average of 4 to 12. So things, for whatever reason, have gone up triple. So what we're doing in this case with the database engine level is saying, automatically use plan 2. So it's gone back and started to use plan 2 automatically. So again, we're taking advantage of the Query Store, and we've enhanced its capabilities in SQL Server 2017. And obviously, this is going to be a theme for Microsoft going forward with the product itself there. So we've got this DMDB tuning recommendations, DMV. We can detect it through that, otherwise force manually. So if we turn on automatic, it's going to do it automatically, but we've got some capabilities as DBAs there. So reverts to the last known good execution plan there. So watch this particular space. That's quite an interesting space. Again, through feedback, and I think in particular with Pedro in the SQL Tiger team, they've added a lot of enhancements to execution plans and things like this. So this is a nice addition to the product that is now baked into SQL Server 2017, but I believe it's in SQL Server 2016 Service Pack 2 as well. Again, the whole world is fixated with CX packet weights. And this is adding more meaningful, or giving you more meaningful information about CX packet weights as well, because we now also have CX consumers as well there. So it's giving you more detailed information about parallelism and where and how we have troubleshooted parallelism. because remember, we've got with CX packet weights, we've got the consumer and the producer. So what we're doing is giving you more information at the consumer level as well. So this could potentially be helping you with data SKUs and things like that over here. So again, you'll see in this particular example, we've just queried the AdventureWorks database. We've got CX packets now actually reported in the show plan XML, and we've got it split up into CX packet and CX consumer as well. So this example is showing you how we've got 26 seconds of CX packet that needs investigation potentially there. And now with SQL Server 2017, and notice you have to install Cumulative Update 3. So again, sort of in parity with what they've done with SQL Server 2016 Service Pack 1. We've now got a CX consumer weight as well as the CX packet weight as well. Okay. So again, just giving you some more information there with being able to analyze your parallelism problems there. Again, you'll notice some other things have been added to execution plans, etc., in this particular space. So again, quite nice for troubleshooting purposes. So we've got SQL Server statistics information as part of the query plan execution as well. So that's a nice new addition to the product. So again, just a screen capture and the XML down the bottom. So I'll leave that alone, nothing to add to that. This is just giving you information about the fact that we have a maxed up option for create and update statistics. So you can now stipulate when you update statistics to use a max stop equal to blah. And again, this requires Cumulative Update 3, at least with SQL Server 2017 going forward. I'm not going to spend too much time here. This is just, again, looking at replication. Can't really add too much to this. So you can see we've got replication, distribute agent, cleanup, batch. So again, allow specifying transactions and commands for distribution agent cleanup job. So you've got this auto batch size there. Okay. So again, some options there. This is probably what I wanted to focus on. So this, again, for my customers and what I'm telling management is this is worth the price of admission. So I would potentially be going to SQL Server 2017 over 2016 because of adaptive query processing. So hopefully you've seen a little bit about this at Ignite or various resources. So this again is V1. This is going to be an evolving story for Microsoft. So something that Joe Sack and a few other guys have been working on at Microsoft. So again, the idea here is that the database engine is providing feedback and queries are adaptively executing better because of the feedback loops provided in the product. So this is and should be a whole session in its own right. So we're not going to cover it in a lot of detail, but what we're going to do is say, okay, this is a new capability in SQL Server. Watch this particular space. This can improve CPU performance, improve query story performance, reduce CPU utilization. So again, for high density virtualization consolidation exercises, this might be a really compelling reason as to why you should be upgrading to 2017 as opposed to 2016. So at this point in time, there is 3 capabilities in this umbrella term of adaptive query processing, which is batch mode, memory grant feedback, batch mode, adaptive join, and interleaved execution. The first one that we're going to do is have a look at interleaved execution. And interleaved execution is basically dealing with a problem that you have with multi-statement table valued functions. So again, if you're more of a developer and or a DBA who does optimization, troubleshooting, you would know that with table valued functions, Microsoft SQL Server uses hard-coded estimations. So with SQL Server 2012, it sort of assumes that our table valued function is going to only return 1 row, so it's fixed. In SQL Server 2014 and 16, they sort of tweaked it, but all they did was tweak it and change the value from 1 to 100. So that's really not solving the problem. So if you have a table valued function that returns a lot larger number of rows, then the execution plans that are being generated can really yield extremely poor performance. So what we want to do is actually have the row count that's being returned by the table valued function. So in SQL Server 2017, if we detect the table valued functions, there's some limitations. This is version 1 of the product. What we will do, as you can see, is materialize the TVF to find out the actual number of rows, which will obviously give a much better estimation of than 1 and 100 and give you much better query performance. So you can see here's the net result where we have a table valued function in SQL Server 2016 and prior. So we've got this TVF on the right-hand side there at the top, and you can see the row estimation is 100, but we've actually generated, what is that, 500,000 number of records instead. So you can see the percentages is just absolutely crazy. It's 527, 597% of the 100 rows that we estimated. So in this particular instance, SQL Server is doing a nested loop, and that's giving us poor performance. So this is the behavior of SQL Server 2014 and 16. It might even be worse with early versions of SQL because the estimation is 1. So if we jump to the next slide, we can see what's happening with adaptive query processor and interleaved query execution. So in this particular case, as you can see, we've got this table value function being materialized. The estimation is correct because it's got the 527,597 rows being returned. So in this particular case, the shape of the execution plan is completely different. And you can see that we're using a hash match, which is giving us much better performance in this example here. Now, the adaptive query processing, no surprise, is tied to the database compatibility flag. So again, used if compatibility flag 140 is enabled. So pay attention to that, because when we upgrade databases in SQL Server, remember that the database compatibility flag is not automatically changed. Now, this is the first release of this particular interleaved execution. So it's going to be only for certain TVFs. Microsoft are going to obviously evolve this, I would hope. So again, you can see some of the limitations. It's going to be a little bit more comprehensive in the background. Read only, not part of any data modification or operations, not eligible if they're part of a cross apply there. And as I said earlier on, it's tied to the compatibility level. And these are some of the performance improvements that Microsoft have seen. So again, I'm not going to spend too much time. You can see the charts there on the right-hand side. The next one, something that I see a lot, where your memory grant information is incorrect. So SQL Server estimates that a particular query only needs 5,272 bytes and actually needs a gazillion bytes of memory. So we're spilling to disk and seeing really bad performance. So with batch mode memory grant feedback, what we're doing is we're detecting the fact that we've got a spill and generating feedback on how much memory was required. So the next time we run this particular query, we will learn from that, and basically the memory grant given to this particular query's execution will be sufficient, so we're not going to spill to disk in this particular case. So this is a phenomenal new feature of the product, because you'll see a lot of this with really bad code, large data sets, and bigger databases. The last one in our adaptive query processing is that we have this batch mode adaptive join. So in this case, what's happening is SQL Server can perform either a nested loop or a hash join for the same query, depending on what it thinks best. So that's the best way of putting it in. So you fundamentally execute the same query, maybe passing different parameters to it, cardinality changes, etc. So again, we can do an inner join or a hash join. So it's an adaptive join. It will change depending on the query's execution. So again, this is worth the price of upgrading to SQL Server 2017 in my particular books, this adaptive query processing. The next couple of slides I'm not going to concentrate on. So again, SQL Server 2017 introduced Graph Database. It's not worth the price of admission. It's a really V1 implementation. I need to be careful because this is being recorded, so very, very primitive. Again, you could conceivably use this, but the graph capabilities in SQL Server 2017 are fundamentally poor. So it's something that's going to evolve. Microsoft just snuck in a bit of introductory support for graph databases in 2017, so just be aware of that. So again, you might have seen some literature on that, so we'll leave it at that. Integration services, just to quickly finish off, you also have a scale out master and worker. So what you have is the capability of running multiple packages in parallel. So you'll see an architectural diagram on the next slide. So you have basically a master and multiple workers. So we schedule the packages to be executed on the different workers from the master. It's not intra package parallelism, it's running packages in parallel across multiple workers, if that hopefully made sense in English. And that's basically for the presentation. So if you have any questions, please don't hesitate to email me there. So victor@bespokesequel.com.au. Always happy to answer questions and even happier to go onto sites and give upgrading, optimization, troubleshoot, architecture advice. Otherwise, I will shut up and field any questions if any questions exist. If any questions do not exist and you're signing off, please have a wonderful year, a wonderful life, a great Christmas, Thanksgiving, wherever you might be in the world. As I said, all the very best, and thank you for attending this seminar. Warwick, over to you.
Okay, well, thank you very much, Victor.
That's got it right.
Okay, so we just got one. Yes, these, well, Victor, are you able to share the slides with me to put them up with the recording of this session on the DBA Fundamentals website?
Let me think about that. Yes, of course I will.
Okay, so probably in a couple of days' time, the recording plus the slides will be available, as mentioned, on the DBA Fundamentals website. You're very welcome. Does anybody else have any questions before we go?
Oh, did you hear that, Chris? That's my son saying hello to the world. I did not tell you to say that. He's only 5. How old are you, Marcus? He's 6. Okay, never mind.
Okay. So, Victor, how does HA across platform work?
Well, HA across platforms doesn't work, you'll recall. Well, okay, if I remember correctly, and Warwick might jump in here, because with Windows, you need to use Windows clustering, and with Linux at this particular point in time, we mainly support Pacemaker. So the idea is you can't have failover from one to another replica if it's going across operating system boundaries, if you like. So the idea here is there's different things that you could do with distributed availability groups and things like that. But unless I'm mistaken, and Warwick, please interrupt if I am mistaken here, you don't actually have HA across operating systems where it's automatic failover. So you have automatic failover in Windows world or Linux world, but then you have to have manual failover across that. And don't forget, you can have synchronous replication between boundaries of operating systems, but you just don't have the automatic failover. Warwick, am I correct?
Yeah, the only thing I would add to that is that it makes a very easy way, if you're wanting to transition from a Windows platform to a Linux platform, then you can have that distributed availability group in place to allow you to get your data across, and then you can break that availability group and you're up and running on your Linux environment. Or if you are having multiple clusters in distributed areas, as per its name, distributed availability groups.
And if you ask that question, definitely talk to me about consulting, because it sounds like you're a rich customer.
Well, if there is no more questions from anybody, I would like to thank you all for attending this month's session. I would like to thank Victor for being our presenter as part of this month's session. For next month's session, we've got data types, do they matter? And that's being presented to us by Angela Henry. So if you haven't already registered for next month's event, it is on Tuesday, the September 11th, same time. And I look forward to seeing you all in a month's time, talking about data types do matter. Thank you very much.
Goodbye, world.